Okay, my friends, we're back again with another Northland refrigerator compressor condensing unit. I just took it apart. I started checking it out. I ran the compressor. It's running about 0 pounds back pressure. It's a 134A system, so that doesn't throw up any red flags at the moment. The condenser fan motor is running. It's getting cold air. I just put it into a defrost cycle. The heater came on. It was drawing 4 amps. I heard the heater shut off through the limit switch, so I know that's working. The only thing is that when I first plugged it in, after I got it up on the bench, I heard the fan motor, the evaporator fan motor squealing inside the compartment. So I took this all apart and I lubricated the bearing on the fan motor. Okay, so now, and I also put this line tap valve on here so I could check the pressure. So the owner of it, the unit, thinks that it has a leak because he had some other refrigeration company out there that told him that you can't get parts and you can't fix them. So he found me on the internet. Here I am checking it out, and at the moment I haven't found anything. There's nothing that's jumping out at me right now. Everything looks normal. So I'm going to wait for it to come out of a defrost and make sure it does come out of a defrost, because a lot of times if you have a bad defrost timer and your refrigerator compressor doesn't shut off, the heater doesn't come on, if it doesn't cycle off and go into a defrost cycle through the timer, then that coil will ice up, and if you take a pressure reading, you're going to get an inaccurate reading, because if there's no heat load over the evaporator coil, the pressure is going to be low, and even in a vacuum, and it could look like a leak. Just to FYI. So just stand by. We're going to do whatever we can, and if we can't find anything wrong with it, we're going to clean it up and send it back. Okay, so I put the top back on. I have to get a little larger screw here. One of these bolts are stripped, and someone else has taken this thing apart, and I could tell from inside they put silicone all over the circuit perimeter. So it was a job to get it off. Okay, so far it came out of a defrost, so it's back running again. Amperage draw 2.6, sounds normal to me. Back pressure, I want to say it's maybe 5, which is normal. Could even be in the vacuum with 134A, so I believe I said that before. Anyway, I need to test this unit out as far as the discharge temperature that's coming out of the evaporator area. You got a port under there that sucks air in, and then goes through the evaporator, comes back out towards the back. So there's dividers there. I have this up on 4x4s so the air can circulate, but the real test would be to seal this whole area off so that the temperature can actually drop and we can watch the pressure drop. And that would be an indication that the temperature is getting colder and colder. So stand by. Okay, here's what I did. I blocked off underneath section, the rear and the front, so that the air that's coming out is recirculating and getting colder and colder and colder as it recirculates. And right now we're down to 4 degrees. 4 degrees is saying to me this thing is running properly. I mean, that's cold. And once it's in the cabinet, of course the temperature would be a little different, maybe colder, most likely. Once the air in the surrounding area, as it drops and drops and drops, the pressure is going to go down, temperature is going to go down, and so you'll be able to see that in your gauge. So right now we were at 5 before, we're just about maybe 1, and so right now everything is looking normal to me. So I lubricated the fan. I don't know if I said that before. Now it's down to 3. It's going down to 3 degrees. We're just going to clean it up. We'll talk to the customer first and see if they want us to do anything while it's here. It's all original. It's got the original timer in it, original compressor. We checked the amperage draw on the compressor, which was 2.3. We put a line tap on here. We're going to have to take that off and put a process port on there, so that means evacuating the system, put a vacuum on it, and then weigh the gas in and leave it at that. And we'll put a maybe change the dryer too. We'll see what the customer says. Okay, so we are down to -2. So looks like everything's the way it should be. -2 is pretty good. I spoke to the owner, and we think maybe he didn't have the harness in properly, or something was not making contact, because he told me the refrigerator was on blowing air, but it was blowing warm air. So I told him that whenever the fan is on, the condenser fan and the evaporator fan and the compressor all run together. So when it goes into a defrost, your evaporator fan motor, your condenser fan motor, and your compressor shut off, and then the heater comes on, and that's your defrost cycle. So we put it into a defrost cycle. It came out of a defrost cycle. It was drawing normal amps, 4 amps on the defrost heater, and the limit switch opened, so shutting the heater off. So I know all that is working. So we're just going to clean it up, drain the refrigerant out, put a process port on here, and recharge the system, weigh in the gas, clean it up, send it back. Okay, that's it. Okay, so here's what I did. I tilted the unit down. The suction line is here, the discharge line is up there, so tilting it this way, there's no way for the oil to go anywhere up any of the lines. That's why I did it this way. And because I want to work on the bottom section here, and maybe put an extra layer of insulation around the perimeter of this bottom section. Alright, so we'll do that, and then we'll get it back up on the bench, and it's all cleaned, pressure washed it, and we're going to take the lid off and fix the bolt here. There's a missing bolt. Okay, so now I have this stick-on foam insulation here, and I'm going to cut it 2-inch strips and wrap it around the perimeter of the condensing unit. Alright, that's a little extra layer of protection against condensation. So now we can sit it right back, right side up, work on the top. This is the original tape on there. I think the owner put this on. It's okay. It's just, I just want to put fresh new insulation. Okay, do the same thing up here. Okay, so now we have this piece here which goes like this. That extra piece of insulation there is actually too thick. It might cause air to escape. I'm going to take this off, maybe put another thin layer of this on in that area. So we put an extra layer of insulation underneath. It's about 3/16 of an inch thick. That's going to help seal all the compartments off, and that's important. So this cover here is a little warped. That's why I did that. And this piece of moisture barrier goes right that. Someone else put this on. I haven't seen that on any unit yet, but that's the way it's going to go on. So next thing we're going to do is put the cover back on. We have one stripped bolt hole there that we have to do something with, and I bought this larger size bolt. We're going to hope that that works. Can we get a wrench for that? Don't over tighten it. A lot of times we tighten these things up with screw guns, impact guns, and we over tighten them and we wind up stripping them out. So the last few turns you should have a sense of feel, because you don't want to strip, and you should actually see the cover being pulled down. And that's about it. That one's tight. Let's see if it's going to fit over that hole. Yeah, that works. So now we have to fix this. There's some insulation that came off there. So we'll put a piece of insulation on there. It also helps quiet the motor down. It actually absorbs the noise. Okay, that'll give us a little protection there. Okay, looks like I pulled out about 3.5 ounces of R134A. That's not enough. So before we pull a vacuum on this thing and recharge it, we're going to pressurize it with nitrogen and see if it holds. We'll let it sit for a couple days. So we are at 160, give or take. 160 pounds PSI. I'll close this off for now. Shut this. And we'll let this sit. We'll open this up a little bit so we can monitor the pressure. And we'll let it sit overnight. Check it in the morning. If it's still there, good. If it starts to go down, then we have to take it apart again and start looking for a leak. Okay, so this thing's been sitting overnight and we're holding pressure. So that's a good sign. No leaks. Now we're going to remove the tap valve and put some process ports on here, pull a vacuum, and recharge it. Now you look, see how my gauge is going down after I close this line tap valve? It's leaking. That valve is leaking. Okay, let's move on. Okay, so we got our process ports on there. We've got, looks like 130 PSI. I'm going to check for solder joints. That looks good. Alright. Looks like we're sealed up. So now, next thing to do, pull a vacuum and recharge. Okay, we're pulling down the vacuum here. Let that run for a while and make sure the system's dry, and then we'll charge it up. This unit takes 7 ounces of 134A. Okay, we are done with the vacuuming here. We're down to, it says below 30, but you know, that's not possible on planet Earth. But we can get close to it, 29.9. Alright, so now I've got exactly 7 ounces of 134A measured into this charging column right here. And so we're going to finish this job up by weighing the exact amount of gas in there, and then we'll run it again and test it and make sure the temperature's pulling down. What we're going to do here, get a short hose. Okay, that's on. We'll open up this, shoot the vapor in, and we'll suck in all that vapor until that charging column is empty. Okay, I took a little piece of insulation off the heat exchanger here to check to make sure that the heat exchanger wasn't defective, and I put that little piece of insulation on there and that cable tie to hold everything in position. It's going in. Alright, I'm going to finish this up. I'm going to get the rest of the gas in there, and then we'll put it back together. We'll test it. We'll run it overnight, or at least until it pulls down below 0, so we know that we've got a good dry refrigerating system. Okay, that's it for now. Okay, so like I said before my phone rang, recap. We took the unit apart, we washed it all down, we checked everything, we oiled the evaporator motor, we evacuated the system, we pressurized it with nitrogen, we found no leaks, we pulled a vacuum on it, deep vacuum, and when we charged it with 7 ounces of 134A, got it back up and running. We re-insulated all the seals, put some new insulation on it, both on the top and the bottom, and then when I finally got it all done and together, the condenser fan motor was making a little bit of noise, so I reached out to the owner, and we decided that we were just going to oil it. So I took the rear cap off the condenser fan motor and resaturated those little pads in there, and now the fan motor is nice and quiet. So that's it. This is on its way back to its owner. Thanks for watching. We'll be in touch.